Right, so today we're going to go through a daily coding question which was asked by Uber. So the question's over here. I'll expand it one more just so that we can get the plus on there. The question's at the top, which is given an array of integers. So here's a question. Given an array of integers, return a new array such that the element at index I of the new array is the product of all the numbers in the original array except the one at I. And then we're given this example here. So for example, if our output was 1, 2, 3, 4, and 5, then the expected output would be 120, 60, 40, 30, and 24. And how does that come about? If I just, I guess if I just, maybe I'll open up a spreadsheet actually if I've got one available. I'll create a new spreadsheet, which in very simplistic terms is this. We've got 1, 2, 3, 4, and 5. Ignore the fact that they're all integers, and then equals. I wonder if it's a product, if we can do that product. Yeah, we can. Which is a multiplication of all of the numbers in this list. And that's where that 120 comes from. So if I just pair it up so we can see the 120, which is a multiplication of all of the numbers in the list, is exactly equal to this 120 here. So that's the first item in the list, which is all of the values, which is the product of all of them. Then when you go to the second item in the list, it's everything in the list, but this time not including the number 2. So, and here everything in the list not including the number 1, well, 2 times 3 times 4 times 5 is 120, and multiplied by 1 is still going to be 120. When you get to the second number, if you have to omit it, so now we're going to omit this second number over here, number 2, we're going to get 1 times 3 times 4 times 5, and that will be 60. So it's kind of like doing this. Equals this one. So we do an equal sign, copy all of them. We'll copy this formula across too. But this time we don't want this value in here. So it's now 60. And we can do the next item in the list in the same way. So let's just copy that across. I'll just do equals that. Copy that all down. And this time remove item number 3, which is this one. And if we copy this formula across, we get 40. So we can see what's happening here. Basically, each time we're omitting something. So we've omitted this value. If I can just get the right. We've omitted this second value here. Then we've omitted the value over here. The reality is this one here, we've actually omitted it too. And if we were to continue, I'll do a continuation of it for the sake of it. Let's just do equals this one again and kind of like copy all down. Copy, paste, and delete that one. And we will get the 30. And finally, if we do all of the same again, so equals this one, copy it down. This time deleting the last item in the list. Paste, we get 24, which is a sum product. And again, all we've done is sequentially remove each index from the list as such. And those are the answers. So we get the 120, the 60, the 40, the 30, and then the 24. So that's our process. We're going to go through and we want to find the product of this list, but missing the blue line effectively every time, missing the index in there. So let's just get rid of all of our annotations over here and move that away. And move that to the side. And that's our example. And then we've got another example over here just to validate our first example in case we didn't understand it, but the same thing with 3, 2, and 1. So we can see that 3 times 2 times 1 is 6. And then we can see that Where is it? Over there. So yes, we see over here we've got, let me just draw it out because I said that incorrectly first time around. But here we omit the 3 to start with, and then we do 2 times 1, and that gives us 2. So we get our first item, and then we go back. So we effectively clear this out. Well, I'll do it in a different color, but this time we omit the number 2, and we include the 3 and the 1, and 3 times 1 is 3. And then finally, for our last one, we disclude the number 1, and we're left with 3 times 2, which gives us a 6. So that's just generally the process of what happens and so what we need to get done. And there's a couple of ways of doing it. And finally, actually, there's a follow-up question: what if you can't use division? So we'll do a couple of different methods effectively. And I did this like ages ago, like 2019. So it's an old question. These questions always keep coming around, and there's all these sorts of like fun types of questions that you can do that keep coming around. So this is like 4 years ago, probably when I was first like learning and practicing a bit of Python. So let's just go over to here, and I've kind of like done it, and this is what I've done. And what the interesting bit is, we've now got ChatGPT, so I'm going to put that in. Let me just remove all the annotations as well. We don't want those. And I originally wrote this just in a pure Python file. Now I'm using this hash space percentage gives us the ability to use an interactive notebook, which is quite nice to use, because instead of having things coming down in the terminal, which I can sort of like remove, I'll keep it here at the moment, but it opens up something in the sidebar over here. So and we'll see that when we actually run it. But this little block of code, all of the code here, gets run sort of like in one go. And in fact, one thing I could do maybe is break it into 2 pieces, but I don't think it will. Anyway, I haven't gone through imports yet, but this is kind of like a standard thing that we do, which is, or we can do, which is we can import a module. And this module that we're importing is the NumPy module. Very, very popular module, probably one of the most popular or most well-used modules in Python. It's an external module. When at least it's external if you just install Python as is from the Python website. I think if you install it using Anaconda, that things like Pandas and NumPy actually are automatically installed as well. But this is an external module, and if you wanted to install it, you would just do pip install NumPy. I already have it installed, but if you did pip install NumPy, it'd run through, everything satisfied for me, but you'd get it'd run through and do all of the code, and then you'd have NumPy available to you. NumPy it stands for numerical Python. Actually, it's a package or a module that has tons and tons of functions in it, and you can kind of like see the list of functions if I just do np dot, like just loads of functions that are to do with mathematical things. So that just a ton of things. The reason why I've imported NumPy is it's got something that's kind of like convenient, although we'll find a different way. We'll see a different way of doing it, but it's got something called np.prod, and if I hover over it, it returns the product of an array of elements over a given axis. So basically it's returning the product of an array of elements in its most simplistic term, which is quite convenient, because what were we doing here? Well, in fact, even if you look at this bit here, if I do the double control, it says product. We're actually looking at the product, the multiplication of all of the values in each list that was created over here. So we want to do the same type of thing here. And I don't even remember why I called it SAP, but start array product. That's probably what it stands for. So I've created this variable, and I've called it SAP start array product, which is just a numpy.product of the start array. So we're given this like example start array. I don't know if did I make that one up, or I probably stuck in a random array, right? So we've got this random start array that's in here. Like random is when I just threw in some numbers probably. And the first thing we want to do is calculate the product of the array, and we can do that with this np.prod, which is the multiplication of all of the items in the array. So it's just convenient for us to do. And actually, I'll run it now. I think I ran it before anyway, but I'll run it now. We can see the kernels connecting, activating Python environment. So let it do its thing. And it runs. And we get this array that comes back. And that is because we've got, well, effectively we've got all of these numbers. If I can even copy them out, maybe. I don't know if I can copy them out, but let's stick them in here. I could even stick them in by the side. We've got a 1, a 20, a 13, 24, and a 15. And we've got this same formula over here, and you can see that the product of all of the values in this array is 93,600, which corresponds to the first item over here in the list. So it looks like it's working nicely, at least for doing the product, calculating the products. That's fantastic. And then I go along and create this empty array. So I just called it prod array. And then I do this loop, and you could argue that you could do this more efficiently. I could certainly do it more efficiently, actually. It just occurred to me that I could use a list comprehension. And the reason why you can use a list comprehension is if you've got this pattern, which is if you've got this creation of, and we spoke about this in a previous video, but if you've got this creation of an empty array and then the appending of that same empty array to populate it inside a loop, then that is that pattern is replicated quite conveniently with a list comprehension. So maybe we'll try and do that as well. So that'll be a modification. That'll be the 2023 version of what was done in 2019. But what happens is we loop through this empty array, so it starts off empty, and then for each element, and that's probably why I used E at that point. So for each element in the start array, we just take this product, and effectively what we do, it's quite a cute little trick, is in order to eliminate this number, we just divide by that number. So if we divided by 2 over here, 2 divided by 2 is 1, so it's nearly like having 1 times 1 over here. And this one's like having 3 divided by 3, which is 3 over here, and so forth. And if I was to colour them in some way, I guess background colour, there we go. This is going to be 3 divided by 3, which is 1. And this one's going to be 1 as well. So it's almost saying, like, don't leave blank. Instead of leaving blanks, let's just divide by the number, because we know that the product of the array anyway, and this one here anyway, we didn't need to do anything for the first one, but 1 divided by 1 is 1. So eliminating that number was sufficient to give us the answer to the original question that was asked, then that would have been a typical interview question that was asked by Uber at the time. Presumably it was, at least. So that's what happens. We go through it, and then finally we can print this array, and that's exactly what happens. And then we've got this second piece here, which is a follow-up, which is what if you can't use division. So, okay, we've done that, we're happy, we've got a result that comes out. And then I've got here, I've just done this same method without dividing, and we can sort of like see it down below. Maybe I'll even put over here, again, because it's new, but \n for a new line. So when we run it, we've got a nice little space between the two, right? So they're the same method. So all of the other stuff is down below. And one thing that I've done here is this print I, which has printed all these numbers down below. We don't really need it, so I could comment that one out. Again, this was from 3 or 4 years ago. I can rerun it again, and now our answers look like this. We've got floating point numbers here. We could have converted them to integers if we wanted to. So if we went back here, I guess we just want the integer part of that, which actually is, I believe, this double dividing sign, which would just give us the integer part of it. So, and we do get that. So there we go. Little modifications that are made to improve our the output, the look of the output. Right? We haven't really changed anything at this point or added anything. I'm still doing commentary effectively on what's there. So that's quite nice. We've got all of that done, and so we're going to do this same method but without dividing this time. So how do you do that? And I've taken one approach, and I did look before on ChatGPT. Just I banged in exactly the same question on ChatGPT just to see what it would do, and it was interesting. Like, it's done a similar approach, although I've used a lot of pops and inserts, and I'm going to run through this. But basically, like this is the newbie version of doing it. This is how one does it when they don't know any other methods necessarily in Python. But I did for I, value in enumerate start array. And remember the enumerate. And if I go to the Jupyter variables here, we've got the start array down here, and I can open it up. Remember that enumerate, it actually exposes the index values as the index values, or so the index as well as the values. So the index values as well as the values. So and remembering indexes start at 0. So enumerate exposes the indices, which is quite nice because you can utilize that. Because if we know our index, we can pop the index. If we know it's index 0, we can remove it from the list. So, and that's effectively the second method, which is really this method here, or at least the original one. So if I was to copy all of this down, in that example, copy and paste it, so like down here. And if I was to remove all of these, I can't remove the first one because everything's linked to it. But if I was to remove all the rest of them, it doesn't have an effect. So both methods, in terms of the output result, have the same output result, whether or not we replace the value with a 1, which was divided by the original the value itself, or alternatively popping the item from the list, removing the item from the list. So we could do both. Now, you'd think that popping an item from a list, and I'm quite sure that that's the case, we could put a timer function in to see it, but I'm not going to do it on this particular one. I might do it on in another project. But popping an item from a list is computationally more expensive than just dividing. In particular, I'm popping an item from a list, so I remove the item from the list. Then we do this calculation, which conveniently up here we've called SAP, which is start array product, which is, so we do this, we calculate the product, then we do an append of the array, and we append our product, and then we put the item back into the list, so that we can redo our next calculation, and it produces the same output over here, which is all quite nice and hunky-dory. But I'm now going to stick in a couple of performance improvements. So one is we can, well, I'll do it as a print actually. Print. And I'm going to put in a, so yeah, let's just do that. Let's try a list comprehension. Remembering that the above was satisfactory, so it's just another method of doing it. I guess because I've got a couple of double arrows there. So we're going to try list comprehension this time. And all we're really going to do in the list comprehension is do all of this effectively in one line of code, which is the whole purpose of it. And in fact, we could even stick it straight into the print statement. But let's just get our product array working. So our list comprehension. So in fact, we can actually copy this, because this is how the list comprehension works. We saw this from the previous one. And then we could do something like E. I'll use E for E. Again, actually, I can just show you the building of the list comprehension, which is quite nice, right? Which is all of this for E in start array. And this is the piece here that goes into here. So now it's this. So it's SAP over E for, I'm just trying to think if we can do that. Yes, we can, because we worked out SAP earlier up here. So we've got SAP over E for E in start array. That's our full list comprehension, and then we can print in the same way prod array. Okay, we could leave this unambiguous by putting in brackets, but it's already unambiguous because it's in front of the for statement and there's nothing else there. So it's literally as simple as this by the looks of it. And we run the code and we've got our try list comprehension, and we get exactly the same numbers out. But even more than that is we don't even need to create this prod array now, because we're using list comprehension. We're going to X that out of there and cut it out and paste it straight into our array, our print statement over here. And we'll also even add the backslash, a new line, effectively \n. There we go, a new line character, so that it looks pretty too. And that's it. So we've got this one-liner in Python. So the beginner's version, it's not really a one-liner, it's two-liners, because we needed to know the initial product, in order to iterate through all of the items and then do the division by E. So it's actually a two-liner and not a one-liner. So really, if I was to copy this one here and paste it down here, or at least I could put the whole thing in one line, because we could X this out of here. I'm not sure, it'd look a little bit too messy, but you could X it out of here and put it straight into the list comprehension and run it like this, and that would be perfectly fine too. So we see that we've got this whole big thing in a full working version of everything that runs in effectively one line of code. And you might argue that it's relatively simple, although I will just Control Z, Control Z, Control Z, and Control Z one more time. And I'll keep it like that because we like it to be a little bit clearer. Like it's not the end of the world using one more line of code to make it look quite nice. So this is repeated here. And the only reason it's repeated here is just to show what it's doing. So we didn't need to repeat line 37 and 27. So I'm sure if I review that in a few years' time, that I'll have an opinion on that or forget why I repeated it. So why have I got a little thingy over there? Probably because I need to do an update. So dot commit and push. I'm hoping that was all that was required. And close that one out, because it's got a little not sure what that is. Let's just run it, make sure. Yeah, it's all working fine. Okay. This probably means I could change or something. Interesting. That's why that little red triangle pops up when it's two lines and not when it's one line or three lines, but yes, interesting. So if the user cannot use division, right, so this is the alternative, then multiply all the other elements of the array, and we can do the same by moving it. So we've done that too. The final part really is, I'm just going to compare it, but I did actually already stick it into ChatGPT. So that was like, where was it? This is what I literally copied and pasted the actual text out of the original question and kind of like pasted it into here. So it's literally a copy and paste of this. I didn't copy this is the problem asked by Uber, because there's no point to that. But I copied that, and I didn't copy the other part yet because I was kind of like, let's give ChatGPT a chance to answer the first version of it. But it's put here to solve the problem. We can first calculate the numbers in the original. We can first calculate the product of all the numbers in the original array. Then for the elements, then for each element in the array, we can divide the product by that element to get the corresponding element in the new array. And here's the code, which is in essence, it looks slightly different, but it's pretty similar to what we've already done. And in fact, it uses this double forward slash to divide to get the integer result from it. And the only difference actually is it's put it into a function over here. So it takes this set of numbers in there. So that's a ChatGPT version of it, and it doesn't use NumPy, right? So here's the non-NumPy version, right? If you want to get the product of the numbers in an array, then you can do this little pattern over here, which is a times for num in numbers, or effectively the product is times equals to the number. So I didn't have to do over here np.products, but I could have done so SAP, and maybe I'll do that in the start, but SAP is equal to, and then I guess it would be right. Okay, I'd have to do for num in nums. That's what I'd have to do, or for e in the original array, which is start array in our case. For e in start array, SAP times equals to, and then e in our case. So that would produce the same result. We can sort of run it and see that. Oops, hold on. Why is that? Not the case. Thrown an error and got a runtime warning there as well. Hold on. Yeah, it looks like I've just got to make sure, because I've used SAP, I better make sure that it's I wonder if got it. I'll just initialize it back to 0 basically, or I'll initialize it. I better initialize it to 1 because then we get everything working again. So I think that would run it. Yes, it does. So we didn't have to import NumPy as NP and use np.product on the start array. We could have done this little pattern here, and again, I guess, could we have done a list comprehension? Possibly, but that effectively, what I've written over here was the, let's put it up, was the ChatGPT version of getting the products. It's a ChatGPT's version. Well, in fact, it does start with product equals 1 up here as well, actually. So, but it's a ChatGPT version of getting the product of an array without using NumPy. And you can choose. NumPy, using NumPy will be faster. So for massive arrays. Otherwise, both are going to be relatively similar in terms of cost, computational cost. So we could have done that. So that was quite interesting. And then afterwards, so ChatGPT did it, and it shows its answers, and the answers are relatively similar to us. And it also mentions this integer division in the second loop, which is actually the same integer division that I put here because I didn't want to have the decimal points at the end of it. When you divide by whenever you divide, even if the result is an integer in Python, and we mentioned this right at the beginning, like in a previous video, whenever you divide, the output is always a float. So you'd have to convert it back to an int. You know, you could use a double forward slash, or you could turn it into an int. So you could do a forward slash like this and take the int of all of that like that, and that would be equally sufficient. So like either or. In a way, I find this one a bit clearer because I always forget what the double / means, but because I've concurred with ChatGPT, it's always nice when you've got confirmation that one works just as well. So let's just go see the second half of the answer now, which is what if you follow up. That's our follow up. What if you can't use division? So what if we can't come along and use this cheeky method, right? Where is it? Let's pull it up. We can't use this cheeky method here of dividing by the actual number itself. So taking product divided by number itself. The alternative was to do the pops of the list, and so that's what we did in our initial thing over here. We went along and we did a pop, and then we worked out the product of the array with the item popped. Then we appended that, and then we put the item back in, and then we went over to the next value in it and popped that and so forth. So let's see ChatGPT's version of the same thing, which is if division is not allowed, we can use two arrays. So are we using two arrays? Yes, we are, because we've got new array and start array. So we're using two arrays as well to keep track of the product of all the elements to the left and right of each element. Then we can multiply the corresponding elements in the two arrays. So it's doing I guess it's a relatively clever way. Let's have a look to get the final result. So in we can use two arrays to keep track of the product of all elements to the left and right of each element. That's an interesting one, because I don't do that. I've enumerated the array and so like iterated through it, thrown an item out and then put an item back in. So here it's a completely different method. It's taking the left hand side of it and the right hand side of it, which is quite interesting. Then we can multiply the corresponding elements in two arrays to get the final result. So it's omitting the first one, so it must be zipping it or something at the end. Times nums. Okay. So it's taken a different approach, which is an interesting, very different approach. The function still produces the correct result and it works without using division. Note that we are using two additional arrays, which increases space complexity by ON. So I guess that's that. And I actually think that the method that I've used here for popping and inserting, I'm relatively sure that that's possibly slower because you're shoveling around items in lists, so you don't want to be doing that, and that this method looks more efficient. Let products left products equals 1 times n. N equals the length of the numbers. Right products equals 1 times n. For I in range 1 to n, okay, left products equals left products I okay. Oh, I see. Right, that's quite nice. What it's actually doing is, what it appears to be doing here in ChatGPT is it appears to be splitting it actually into two arrays. So it's going along and going, that's my left product, so like my left hand side array, and that's my right hand side array, and I miss out this item in the middle, this yellow one. And then again, I'm going to go for the next iteration of the loop. So if I just move this slightly out of the way or move it, I'll move it back into place. But if I go through this next iteration of the loop, because there's a for loop, and I just got to make sure I put this all back in place, that this array now is comprised of these two, and the other array is comprised of these ones, and the blank is over here. So it's kind of like we'll just split it and make two new arrays. So instead of doing a pop and an append, it just says create two arrays. So I wonder if which one's actually quicker. That's a nice side piece to test. And this is the interesting thing, or the nice thing in Python. There's supposed to be a Pythonic way, as in the like most optimal way of doing something. But we see that we've got three. We had three methods here. We certainly had this top method, which we both agreed on in a way, like myself and ChatGPT. Like maybe that's the consensus method, and possibly the fastest one. But then we had these two alternative approaches, and we could potentially like measure the time between them, or like there should be one way that's the agreed better way of doing it, because it's uses less memory. And I'm going to say in a way here, if you modify this, possibly this uses less memory. I'm not sure that it does though, because a new array ends up being the same size as a start array. So I think I'm relatively sure that using pops and appends would be slower than creating two arrays and multiplying them, although you're continually creating arrays. So they're both costly. The second method in both ways are more costly, because creating arrays or appending arrays are going to be more costly in terms of time than just looping through an array quite efficiently and dividing by a number. So the top method is going to be a more efficient process. And that's pretty much, I'll do a Control J. I think that's pretty much it. So that was a daily coding question, and I'm going to do, I think I might go through a few more of them, like, because it's just quite interesting and I've got them there already. And the reason why is because actually I was using this Remote Explorer in Visual Studio Code, which lets you actually connect live to GitHub. So I've got available to myself all of the, I hit Control S. If I do F5, configure the, okay, I need to configure open launch.json. I won't do that now. So that's interesting. I need to get my launch.json working. That's not going to be part of this file. But yeah, there's a Remote Explorer, and that lets you connect directly to the original, to the repository, basically to a GitHub repository. So I can see everything in the GitHub from there. So I was just checking that all of the numbers are correct and everything. I'm going to hit save, and then I can go over here and sort of like do this commit and push. You have to always put a message in. Sometimes I don't want to put a message in because it's like basic stuff, but you have to put a message in and it's kind of like pushed. So it's quite a nice thing to have. So these just these little extra bits that we've got available to us. And that's pretty much it. So that is our, I don't know what even to call it really, but I've called it new product array as a file, because it's the product of the previous array that was Git, or it wasn't even an array in Python, it's called a list. So I should have called it new product list. But it's this new list that's created from a previous list, but omitting one of the items from the list. And that's pretty much it.